Okay, so now let's try and solve the same problem, but let's use some actual numbers this time. Okay, and that should make things a bit more clearer. So, well, we can only assume the values of the exogenous variables and the endogenous variables we will be calculating. So suppose I naught, which is investment, is equal to 50. Suppose G naught, which is government expenditure, is 150. So these are just numbers I'm making up. What else do we need? Suppose A, which is autonomous consumption or consumption that is free of income, is 125. B, which is MPC, is suppose 0.75, which means you consume 75% of your income and save the rest. And what else? D, the lump sum tax amount is, let's assume that this is 20. And T, the tax rate, let's assume that it is 8%. And now if we construct the three equations that we had, what we get is y equals to c plus 50 plus 150. Second equation becomes c equals to a, which is 125 plus 0.75 y minus t, and t is equals to d, which is 20 plus the tax rate times y. This is what we have now. And no, wait, sorry, this is 150. Okay, so as always, what we are going to do is we're going to take all the endogenous variables on the left side and keep everything else on the right side. So as well, the first equation becomes y minus c is equal to 200. The second equation will be 0.75y minus c minus 0.75 t equals to minus 125. And the third equation will be 0.08y, no c here, minus t equals to minus 20. So this is, of course, equation 1, equation 2, and equation 3. We have three equations, we have three variables, so a 3x3 system of equations, and we can solve them. So let us first start off by converting this into the matrix form. And that gives us 1, minus 1, 0, 0.75, minus 1, minus 0.75, 0.08, 0, minus 1. This is the coefficient matrix divided by YCD. And this whole thing is equal to 200 minus 125 and minus 20. I think some of you may be struggling to see this color. I'll just use a darker color, suppose green. Yeah, this is probably better. Okay. So as always, this is the coefficient matrix. This is the constant, the variable matrix, and this is the constant matrix or matrix of the parameters. Okay. So we're going to try and calculate the determinant of A, which is 1 times 1 minus 0 plus 1 minus 0.75 plus, okay, I'm going to use my calculator for this. I get 0.75 times 0.8, which is 0.06. So what I get is 1 minus 0.69, so 0.06. 0.31. That is the determinant of A. Okay. Now we need to construct AY, AC, and AT. So AY is going to be 200 minus 125 minus 20 minus 1 minus 1 0 0 minus 0.75 minus 1. And so the determinant of AY is going to be, let's say, 200 times 1 plus 1 times 125 minus 15. So we get 200 plus 110. So 310 is the determinant of AY. Let us now construct AC, which will be 0.75, 0.08 minus, no, sorry, 200 minus 125 minus 20, 0 minus 0.75 minus 1. And so if we calculate AC, we're going to get 1 times 125 minus 15 minus 200 times, let's see what we get, minus 0.75 plus 0.6. So we have 110. Once again, I'll need my calculator to do this. Minus 0.75 plus 0.06. Okay, this times minus 200. We get 138 here. So 248, just a determinant of AC. And if we construct AT, we are going to get 0.75, 0.08 minus 1 minus 1 0, and 200 minus 125 minus 20. So if we calculate the determinant of AT, we are going to get 1 times 20. Actually, I'm going to use the third row. That is going to be easier. As always, you guys can use any row or any column that you want to. This just looks easier to me. So I'm going to get 125 plus 200. Wait, let me verify that. Yes. Minus 20 times minus 1 plus 0.75. So what we get here, I'll use my calculator again. 0.08, 125 plus 200. That gives me, so I get 31. So the determinant of AT is 31. And now I can go and calculate the values. So Y star, the equilibrium Y, is given by determinant of AY divided by determinant of A, which is 310 divided by how much was it? 0.31. 0.31. So equilibrium output or equilibrium income is 1000. Equilibrium consumption is given by AC divided by determinant of A, So 248 divided by 0.31, and I'll use my calculator again. This gives us 300. And equilibrium tax is given by AT divided by A is 31 divided by 0.31, so 100. So you see, we started off with these three equations. Some of all the exogenous variables were known to us. So we knew investment is 50, government expenditure is 150, autonomous consumption, MPC, this. So we knew all the exogenous variables, everything up here. And what we had to calculate was the endogenous variables. And as we have talked in the previous video about, the endogenous variables are Y, C, and T. So first of all, we organized the system of equations in a way where we have all the endogenous variables in one side and everything else on another side. And then we convert it into a system of into matrix form. And from there, we just use Cramer's rule to find the value of Y and C and T. Of course, we've used Cramer's rule because in this lecture, we're talking about Cramer's rule, but remember that that you could have used matrix inversion as well. So all you would have had to do is you had A, which was the coefficient matrix. From there, you just had to calculate the A inverse. And so you would have ended up this, which would have given you the values of X, Y, and T, Y, C, and T. And this is what it would have looked like if you had used matrix inversion method. But at the end of the day, either either method is valid. During your exams in quizzes and midterms and finals, I will specify which method you have to use, Cramer's rule or matrix inversion, to solve a system of equations. And if I don't do that, then you guys are free to use whichever method you find the easiest. It's really up to you guys.